So yeah, my name is Julien Niset. I'm one of the co-founders at Argent, and I will talk about accord abstraction. It's been mentioned a few times today, which I find very exciting, but I'll try to shed some light on what it is. As some of you may know, at Argent, we've been building a smart contract wallet on Ethereum for the past 4 years. And we've learned a lot of things by doing so. One of the things is that we are more than ever convinced that it is the right model if you want to scale non-custodiality and really scale the ecosystem to billions of users. But we've also learned that on Ethereum, on L1, there's actually a lot of complexities. Why? Because Ethereum was designed for externally owned account, EOAs, which are first-class citizens, and smart contract wallets are and will remain, without account abstraction, second-class citizens. And so you need to use some kind of tricks to achieve your goals. For example, you need meta-transactions. And for that, you need relayers that need to scale and so on. So there's all that added complexity. And as I will try to convince you, account abstraction is the right solution to tackle that. So I will first start by recapping what accounts are on Ethereum. You certainly all know what it is, but I think sometimes it's interesting to take a different perspective on things we know. This will lead us to the limitations. From there, I will introduce account abstraction. And I will conclude by giving you some use cases of what we can actually achieve with account abstraction and what we are today achieving on Starknet and hopefully on zk-Sync very soon. OK, so Ethereum accounts. As you all know, there's two types of accounts on Ethereum: externally owned accounts, or EOA, and contracts accounts. The state of Ethereum is basically the state of these two types of accounts. The state can only be updated by transactions, so you go from one state to the other by applying transaction on the previous state. And this state can only be changed with external triggers. So every transaction must be initiated by something external to the blockchain. It cannot change its state by itself. That means that all transactions must start from EOAs. An EOA has three key properties. It has an address for identification, of course. It has a nonce to make sure that transactions are unique. And there's a balance to pay its fees to miners. And a user will own an EOA through a pair of cryptographic keys. OK? A pair of public and private keys. I will not get into the details. Again, I'm sure you all know that very well. And we can also call that, a signer, which I will use in this presentation. And how is this signer and this EOA linked? Because the address of the account is derived from the public key of the signer, and only the private key can initiate transactions from the account, right? And on Ethereum, we don't use an arbitrary signature scheme. We use ECDSA on a very precise elliptic curve, SECP 256K1. It's not that important, but what matters is that all this is hard-coded. On Ethereum, this is how it has to work. And all this is really hard-coded in the EVM. So just summarizing, we basically have a user that has a signer, a pair of private and public key. And on the Ethereum chain, we have an account which has an address derived from the public key, a nonce and a balance, and then some EVM logic to validate and execute transaction. And again, not any EVM logic, really something that is hard-coded. And I think this image kind of illustrates that on Ethereum, these two concepts, they are kind of two sides of the same coin. Right? If you have the signer, you actually automatically have an account. I can right now generate a pair of private and public key on my computer, and it automatically is associated to an account that I can control on blockchain. And I mean, that's very powerful, but as you will see, there's also some drawback. Why? Because the signer is the object the account is the object that holds your token, and the signer is the object that is authorized to spend your tokens. And these two should be two separate concepts. But on Ethereum, they are really tightly coupled. And why is that a problem? Because if the signer kind of is the account and vice versa, if you lose your signer, that means you've lost your account. If I have your signer, that means I have your account. And there's basically nothing to do against that. I mean, we've all heard thousands of stories of users using their private keys, using their seed phrase, or interacting with a wrong website. There's basically no safety nets. So what we've built is a financial system whose entire security relies on users managing a single secret, a private key that cannot be lost or compromised. And again, just emphasizing, there's no safety net. There's nothing built in. As a user, you are forced to really being able to manage this single secret. And if you do something wrong, you're completely doomed. And I mean, that has kind of worked so far. Again, we can discuss that. I'm not completely convinced. But clearly, this will not work for mainstream adoption. If our goal is to scale this ecosystem to billions of users and less tech-savvy users, I'm personally convinced that it will not scale and it will not work. So we need a better solution. So can we do better? And why is that relevant in the context of this conference is because we believe that L2 is the perfect opportunity to improve some of the choices that were made on Ethereum, right? If you think about account abstraction, Vitalik has been talking about it, I think, since 2016. Every year he proposes a new design. But of course, it's very complicated to bring that to Ethereum because there's a lot of users, there's a lot of funds, and it's a drastic change. On L2, we start with something like on a blank page. So I really believe that this is the right moment to make this kind of change and improve the ecosystem as a whole. So saying that, what is account abstraction? Well, it's quite simple. It's the idea to decouple the signer from the account. So now there are two completely separate entities. In practice, the account will be a smart contract that defines with its own logic what a valid transaction is and how to process a valid transaction. That means you can use a different signature scheme. Maybe you don't want to use ECDSA, or maybe you want to use ECDSA on a different elliptic curve. Or maybe you want to have multiple signers, which is what we do with multisig. Now you can have native multisig, where you program your account that every transaction needs to be signed by n of m of these signers that you've defined in your contract. Or maybe you want to rotate your signers. I mean, the possibilities are really endless. And in that design, your signer is really what it should be, is just some cryptographic material to authorize transaction. And as you've probably heard today, there's already 2 teams on L2 that have committed to implement account abstraction, Starkware with Starknet, and we've been working closely with them, and ZK-Sync as well, and we are as well talking with them a lot, and I was very excited to have discussion with Bobin from Polygon Maiden that said he's also interested into account abstraction. So I think it's very exciting to see all these teams recognizing the value of account abstraction and doing what they can to bring it to users. So on Starknet, to be a little bit concrete, we've been working with Starknet and Martin from OpenZeppelin on defining what should be the interface of an account. Because of course, if you can, every account is a contract that you can deploy and customize to your need. You need to have an understanding of what's the interface, like the virtual machine that will process transaction needs to make sure there's certain transactions present on that account. And so on Starknet, the interface of an account is very simple. It has just these 4 methods. The nonce is very obvious. 2 important ones is the execute and validate. Is what the OS or the VM will use to validate that the transaction is valid and then execute it. And again, the validate, you have that hard-coded in Ethereum. When you make a transaction, the EVM will check that the nonce is valid, that the signature is valid, that you have enough ETH to pay for the miner fee and for the transfer and so on. So all this is already hard-coded in Ethereum. The idea of account abstraction is to let whoever deploy an account control and chooses his own logic. The validate method, I will not get into that, but for security reasons, the validate method needs to have some constraint. But basically, the OS or the VM just cares about these 2 methods. The third one is actually very important, is the ability to validate an off-chain signatures. On Ethereum, because the signer and the account are the same thing, if you're building a dApp and you ask your user to sign some material, say EIP 712, you can actually verify locally on your dApp that the signature is valid because you can just apply EC recover, and because the signer has the same address as the account, you can make sure that the signature is valid. If the account and the signer are different, you actually need to ask the account, is this a valid signature for yourself? Because maybe what was the signer 5 minutes ago is now a different signer in the account. So as a dApp developer, that's something that you need to understand, is to verify off-chain signature. You can no longer do that locally. You just need to ping the contract and say, hey, is this valid for you? And the contract will tell you yes or no. So if you want to know more, there's actually 2 implementations on Starknet in the OpenZeppelin repo and in the Argent repo. Oh yeah, and as an additional, because we're starting from something new, we've actually pushed to include multi-calls as well. So on StarkNet, for example, and I believe on Zk as well, there will be native multi-calls. So no more ERC20 approve, and then 5 minutes later, when your transaction is mined, you can actually execute a transaction. No, you can actually chain a sequence of operation in one transaction, and again, all of this is native. So summarizing for the app developers, there's basically 5 things you need to remember. The first one that can be a bit of a complexity is that no account needs to be deployed. On Ethereum, as I said, you have a key, you have an account. With account abstraction, you need to deploy your account as a contract. But again, this should be handled by wallets, and as I will show you, that's what we do today. But you still need to account for that. The address of the account is no longer derived from the signer, so because it's a smart contract, you need to compute the address like any other smart contract. You should not assume that a transaction has only one signature. So again, you can have multiple signatures to alpha transaction. Already mentioned off-chain signature, and that's very important for the app developers. Off-chain signatures needs now to be validated with the account, should no longer do locally. And as a bonus, you have multi-call. And what's really cool is that that's the only thing you need to know. If you build on the chain with account abstraction, that's really the 5 things you need to know. And you can enjoy the benefits. Talking about the benefits, I'll try to be a bit more concrete and give some use cases and some potential direction that we've been working on at Argent. And I will illustrate them with Argent X because it's actually a live product. So Argent X is the first wallet on StarkNet. You can think of it today as a MetaMask. In the future, it will be 100 times better. But just for the mental model, it acts like a MetaMask Chrome extension. You can, make transactions, interact with dApps, and so on. And of course, I invite you to check it out if you want to. So how does it work? Typically on MetaMask or wallet on Ethereum, your wallet has actually 2 components, the user-facing UI, and then the cryptographic material, your keys. With account abstraction, you have a 3rd component, which is actually a contract account on-chain that your wallet needs to manage, so deploy and interact with. But again, this should be transparent to user and dApp developers. And so like your MetaMask, when you click on a button on your dApp, it triggers the wallet to open, you ask to confirm a transaction, you say yes. The wallet will package that according to your account contract, call the validate and execute method, and this will interact with the target dApp contract. So what can we improve on that? Well, because you can program your account, you can imagine that you introduce a second key. And that second key, you can give it to a service that you choose. That will call it a fraud monitoring service. That means that every time you make a transaction, the wallet can transparently send the raw call data to that fraud monitoring service and say, hey, is this a legit call? Is it valid? Is it secure for me as a user? The fraud monitoring service can use whatever business logic it wants. It can, inspect transaction on chain, use past transaction. It can use a blacklist, a decentralized blacklist, a whitelist, whatever. You can have multiple fraud monitoring services. So they can all have their logic. If the fraud monitoring service considers that the transaction is valid, it will transparently return a signature, and then the wallet will send that to your account contract, which will interact with the dApp. So that's really cool. This is transparent to the user. So now, suddenly, you no longer need to be afraid to interact with the wrong dApp or interact with a phishing website or with, because you know that there's this fraud monitoring service that will process the raw call data that you're about to make and give you information and tell you if it's secure or not. So that's the happy use case. Of course, if you click on this do something button, but actually this time you are doing something evil because it's a hacked website or it's a scam and so on. You will do the same. Transparently, the wallet will send the raw call data to the fraud monitoring service, which will say, wait, this dApp is on my blacklist, or I've detected on chain that it's been flagged as scam. I will not return a signature, and I will tell you as a user, no, this is not a transaction you should do, and these are the reasons why this transaction has been blocked. And of course, you have the in-between, where you're interacting with an unknown dApp. Maybe the fraud monitoring service doesn't know that dApp. Or maybe you've told the fraud monitoring service, I want to set a daily limit of X, and suddenly you are going over that daily limit. So the fraud monitoring service may say, I don't know. I don't know if it's black or white, if it's green or red. Just confirm that you are you. Here are the risks, and just prove me that you are you. And then you do whatever you want with your account. So you can do that with 2FA, and the fraud monitoring service will give you back a transaction. What's, I believe, really interesting is that this is the kind of experience you see today on modern banking application. Except that this fraud monitoring service is not a bank, it's a service that you choose and that you fully control. You can replace it at any time. It can actually be you with a hardware wallet if you want. So you have the benefit of adding safety net to your blockchain experience in a non-custodial way, because as a user, you still have the full control. And you can imagine a world where there's different fraud monitoring provider, and you can choose one, but then go to a different one in the future for whatever reason. So that's one use case. I think through account abstraction, we can bring the idea of having this non-custodial fraud monitoring at the account level. And by the way, what I just described, we've been doing that with our vault. For those who remember the Argent vault, we used to have daily limit. We used to have all these safety nets that were programmed on chain. But of course, as gas increased, it became quite expensive. But it's the ability now we can actually bring back this experience on layer 2. Another thing that we've been very vocal about at Argent is social recovery. So again, very simple idea. Imagine that, again, say you have 2 keys. The second key, you give it to a friend or to a trusted party, someone that you trust. And you say that key in your account, in your smart contract, the logic is programmed that this key cannot trigger transactions. So it cannot spend token. It cannot interact with the dApp. But what it can do is that if for some reason you've lost the signer, the owner of the account, you can actually contact that friend, that trusted party, and say, hey, can you reprogram my account and set up a new owner? So now suddenly you no longer need to remember about seed phrase or back up your seed phrase, because your original signer is just assigning material. If something wrong happens, you can always contact that trusted party, and they will reprogram your account to set up a new key. And of course, it can be one trusted party, but it can be N of M trusted party that collectively need to ask to reprogram your account. In practice, there's a little bit of not complexity, but not logic that needs to be put into account to make sure that that trusted party cannot abuse your account and so on. So on Argent X, we have a time delay of 7 days. It can be canceled, but what's interesting is that it's 100% non-custodial. As an owner, you are fully in control, and that enables you to get rid of seed phrase. And again, I illustrate the first slide with a service. It can be N of M friends if you want. It can be your bank, your lawyer, or again, it can be yourself with a hardware wallet. So you can actually have a hardware wallet that you put in a bank, in a safe, for what hardware wallets do well. But actually, for your everyday life, you still use a convenient and usable wallet, and you only use that hardware wallet as a security mechanism for recovery if something goes wrong. A third use case that I think is quite interesting as well, on Keros, some crazy developers built a library to support SecP 256R1. So it's another elliptic curve that can be used by ECDSA. Why is that interesting? Because that's the curve that is approved by the NIST and that you find in the secure enclave of your phone. So suddenly you can imagine to create an account where the key can now be secure in the secure enclave of your phone. And so you can sign transaction with your phone. So it's like turning your phone into a hardware wallet. Suddenly, everybody in this room has actually a hardware wallet in their pocket. And you can implement that at the level of the account contract. And so to conclude, I hope that I've slightly or tried to convince you that account abstraction is really a game changer for the usability of self-custody. And I do think that's important. I think that if we continue building an ecosystem relying on EOAs, what will happen is that either the ecosystem will not grow because there's a lot of people that won't be able to access the ecosystem, or actually there will be centralized providers that will offer to take custody of your keys for yourself to enable this experience that the majority of users want. And if that happens, we will actually lose the self-custodial aspect of the ecosystem, and I believe that we would have lost. So I do think that today we need to address this question and try to fix them by the technology that we are building. And again, layer 2 is an amazing moment, I think, to address these opportunities. So I've illustrated how we can provide some of the safety nets that we believe are needed to onboard the next billion users to the blockchain. And again, layer 2 is the right opportunity for that. As I've also discussed, Starknet and zk-Sync have both committed to implement native account abstraction, which is very exciting, but there are more layer 2s in this conference. And I do think that you should all try to consider, if possible, adding account abstraction as an add-on to your system, like the last EIP proposed by Vitalik and some other people. I do think that it's interesting, but it will not fix the problem that smart contract wallet will always be second-class citizen. I do believe that we need to bring account abstraction at the protocol level if you want it to succeed. I will mention the last point as well. Like everybody else, we are hiring, but more than that, if you're excited about account abstraction, first of all, come talk to me. And of course, if you want to build on that, you can check that page, you can contribute. I will be happy to discuss. Thank you.
Thank you so much for an amazing presentation. I see that the choice for ZK EVM and other systems now doesn't seem to be as obvious, right? There's one more argument for the red guys over the yellow guys here. So, yeah, I mean, I think, I'm looking forward, to see how the future is going to look like eventually, right? Because, I mean, it's going to be fun. So, any questions from the audience? Yes. You're close enough. I'm not going to throw.
Thanks. You mentioned that one of the few drawbacks is that you need to initialize an account for this to work. My intuition tells me that it should be possible to have some sort of default account for a signer, so that I would be able to send you some ETH and you would be able to later initiate it on-chain, and especially with multi-call, you might do that as a step where you send the ETH at the same time as you initialize it. Are there fundamental reasons why you can't do this, or is it possible?
No, there is not. I believe that's probably one of the directions zkSync is pursuing. So to say that by default you have an EOA-like account, so if there's nothing there, then you get that account by default. I think that's what they are doing. So it certainly can be done. The question is, you should have the possibility to upgrade that account afterwards. So I think that opens some other questions down the road. But personally, I don't think that's a blocker in the sense that we've had Create 2 on Ethereum for some while, and we have Create 2 on Starknet as well. So as a user, you can imagine an experience where actually we show you the address of your account. It doesn't matter if there's a contract yet, because you have the guarantee that using the private key that you have, the signer or whatever, you control an account that can be deployed at that address. So you can make an experience where the user onboards, he sees an account. In any case, you need funds, right, to start transaction. So the first thing a user needs to do is to provide money on that account. And as soon as money is there and he makes a first transaction, you can build on that with the creation of the account. So I do believe that it's a little bit of complexity, but it will easily be managed by wallet providers.
Thanks.
Any more questions from the audience? I do have one question, actually. I was actually wondering, because what I find in practice that trying to explain EOA accounts on current Ethereum for new users, that seems like almost impossible task for most people that are not technical. But that stuff looks even more complicated on a technical level, right? Do you think that we will be able to actually achieve a certain level of abstraction so that your proverbial, grandpas and grandmas, they will be able to actually use it as easily as they use the current banking system?
I personally believe yes. I think part of the complexity of EOA is because you need to get into cryptography, right? You have that private key, you have that public key. I think these are complicated concepts. If you tell someone you have this account there, and this is the remote control that controls that account, I think that's simple enough for people to understand. But in all generality, yes, I do believe that we'll find at some point the right level of abstraction to explain this concept. Is it simple to explain account abstraction? Probably not. Is it more complex than EOA? I don't think so. Yeah.
All right, thanks so much again. And yeah.
Thank you.